6 and 7 say, solve the inequalities below, express your answer in an inequality and on a number line. Be sure to include at least one test point with work shown to prove your solution is accurate. So I'm going to start with number 6. And I want to start off by finding the boundary points on my number line. So I am going to treat this inequality as an equation to get those boundary points. So this is going to be x squared minus x minus 13 equals x plus 2. We've got a quadratic on our hands. Let's get all of the terms on one side of the equation. Okay, x squared minus 2x minus 15 is equal to 0. We need to factor this. Well, we can factor this to solve for x. You can use the quadratic formula if you're more comfortable with that. But this is factorable. Two numbers that multiply to negative 15 and add to negative 2 would be negative 5 and positive 3. So x minus 5 times x plus 3 is how we can factor this. And then we can, from here, use the zero product property and set each factor equal to 0. X minus 5 equals 0, x plus 3 equals 0. Solve these two equations, we get positive 5 and negative 3. Actually, I won't box these in. These are just the boundary points. So on a number line, we would draw our boundary points on 5 and negative 3. So let's draw that number line. Because my original inequality was less than, that means my boundary points are going to be open circles. So open circle on positive 5 and open circle on negative 3. Now I need to test at least one point on this number line to see where my solution region is, to see where I'm going to shade. Okay, you're welcome to test, and I encourage you to test just to be thorough. One value from each region, something from over here, something between the 2 points, something over here, but just one point is enough. Let's test 0. So if 0 works, we're going to shade that middle region since that's where 0 lies. We're going to plug this into the original inequality. X squared minus x minus 13 is less than x plus 2. Okay, 0 squared minus 0 minus 13 is less than 0 plus 2. These terms all cancel out, so we're left with negative 13 is less than 2, which is a true statement. 13 is less than 2. So that means we will shade the region where x equals 0 is, so in the middle. Okay, all of this. Our last step is to just write this solution as an inequality. So what does it mean that we've shaded all numbers between negative 3 and positive 5? That means that x is between, again, negative 3 and positive 5. X is less than 5, but x is also greater than negative 3. Our original inequality symbol was less than, so our solution should have less than. Okay, what I mean by it should have less than is that it's not going to have little dashes underneath. Okay, but there's our complete solution. And again, we did test 1 point to prove that our solution was accurate. So we've got 6 done. Now let's move on to problem number 7. Okay, the absolute value of 3x minus 2 is greater than or equal to 10. Okay, right away I can tell you that these boundary points for number 7 are going to be closed circles because of the greater than or equal to. Let's figure out what those boundary points are going to be, though. We'll treat this as an equation. Okay, 2 numbers can have an absolute value of 10. That could be positive 10 or negative 10. So we're splitting this up into 2 equations. If we solve both for x, we're going to get x equals 4 and x equals negative 8/3, which is negative 2 2/3. I keep wanting to box these solutions in, but they're not the solutions, they're just the boundary points. All right, so let's draw a number line. Closed circles on my boundary points, so 1 on 4 and 1 on negative 2 2/3. Let's see where we're going to shade. We'll test a point, at least 1 point. Okay, let's test 0 again. If 0 works, we'll shade that middle region where 0 is. And 0 is not always going to be in the middle of the 2 boundary points when you're solving equations like this. It's just worked out that it's been like that for us, but you could test any point. Okay. Here's our original inequality. We're going to plug in 0 for x. 3 times 0 is 0. 0 minus 2 is negative 2. And the absolute value of negative 2 is positive 2. Now this statement is false because 2 is not greater than or equal to 10. What that means is we're not going to shade where 0 is. We're not going to shade that middle region. We are going to shade our outer regions here and here. Okay, what are our inequalities going to look like algebraically? Well, we've got all numbers greater than or equal to 4 shaded, so x is greater than or equal to 4, and then x is less than or equal to negative 8/3. If you're not sure how to orient your inequality symbols, again, a little shortcut is we've got this shading pointing to the right. Our inequality is kind of pointing to the right. Similarly, we've got shading to the left and an inequality pointing to the left. So there's our complete solution. We are done. Make sure that you have both the number line and the inequality written algebraically.